Good afternoon, anyone who's joining us online. We're going to start this session in just about 1 minute. Just bear with us, and we're looking forward to chatting with you. Good afternoon, everybody. Welcome to our session on small modular reactors. My name is Warren Mabey. I'm a professor at Queen's University. I'm speaking to you today from Kingston, which is on the traditional territories of the Haudenosaunee and the Anishinaabe peoples. I know that people joining us will be from many different traditional territories or unceded territories. Please take a moment to think about where you're seated and the people that have come before. I'm delighted to be able to speak to you today on the topic of small modular reactors, and I'm joined by two very distinguished panelists. I'm going to take a few minutes just to set the stage before I bring the panelists on. If I could get the slides up, that would be great. So the purpose of today's session is to bridge some of the gaps between fundamental research, industry initiatives, and policy in the space of small modular reactors. And if we could go to the next slide. What I'd like to start with is a little bit of a review of where we're at in the world. This is the world's energy supply or energy consumption. You can see that it's dominated by fossil fuels, oil, coal, and natural gas. There are some interesting trends in the way that consumption of different energy forms have trended over the last few years. Interestingly, we've seen big increases in renewables as the world starts to get very serious about climate change and very serious about moving to net zero emissions. We're also starting to see growth in the nuclear sector, and you'll see nuclear is the gold wedge on this slide. It's about 5% of the world's energy right now, and it is increasing slightly faster than world energy consumption is increasing. So we're seeing growth in the nuclear sector around the world. If I could have the next slide. This is Canada. Canada is about 2% of the global energy mix, which is interesting because we're only about 0.5% of the world's population. Our energy consumption has trended up since 2010. In fact, in recent years, it started to go up a little bit more rapidly. We've seen lots of changes in coal use and natural gas use, with coal dropping and natural gas increasing. Lots of increases in renewables. Nuclear, which is about 10% of our energy mix, has remained fairly constant through that period. We haven't built any big new nuclear plants in that time. We've seen some reactors idled and some others brought back online. So there are little bits of changes in the nuclear mix, but not a lot. And that's important because we're now facing some decisions about our future energy mix. And you're going to hear about the technologies and the opportunities that nuclear brings. So the challenge, we sit at about 730 megatons of CO2 equivalent emissions every year. So our greenhouse gas emissions are up at about 730 megatons. I think most people online will know Canada has committed to net zero by 2050 as part of our commitments to keeping global warming at a reasonable level. You can see that our emissions are dominated by oil and gas and by transportation, by buildings and industry, agriculture, and in part by electricity. And this is an important graph to take away because all of these sectors will have to change as we move forward towards net zero. If you can go to the next slide. We're going to have to change the way that we do work and that we do business in virtually every sector of Canada's economy. That'll mean changing industrial practices. It'll mean building better buildings. It will mean revamping the way that we move goods and people around. In the industrial sector, we've got to reduce emissions by about 70 megatons per year by the year 2050. And we can only get there by changing the way that we power the sector and by the way that we do work, so how efficient we are in doing work. We need to deal with our buildings. So the buildings that are dotted across the landscape, we have over 15 million individual houses. We have many million other buildings within the country. We've got to look at how we're heating and cooling those. So we need to look at insulation. We need to look at changing the fuels that we use, and new technologies like heat pumps and new architectural designs are going to come into play. When it comes to transportation, there's about 110 megatons of CO2 that can be addressed by switching to electric vehicles. That's the passenger vehicle side of the equation. There's another 65 megatons that can be addressed through fuel switching or through electrification. And that's in the moving goods and moving products around the trucking industry. But what you're going to see from this is that a big part of the savings and the emission reductions that need to happen will come from increased electricity use. And how we get that electricity is what's important. Our session today is about nuclear power, and nuclear power is a natural complement to the renewable energies that are being developed. A lot of emphasis has gone into developing renewable energy in recent years, and I'm all for this. There are lots of green ways to generate electricity. Nuclear power is a great complement to those renewable energy sources, because nuclear power can provide the base load. It does it in a clean way. It does not have greenhouse gas emissions. It's not to say that there aren't concerns. We do have concerns about waste. We do have concerns about the overall environmental impact. But we know that new technologies are emerging that can use these different fuels, maybe able to use the waste streams from the old plants. We know that the timeline for nuclear is challenging. The Generation 4 plants or reactors may not be available for a decade. It may take 15 years before we see that. We're going to talk about that. We know we need both industry and government leadership as we start developing this next generation, which is going to focus on small modular reactors that can help us to deal with these problems. So with this, I would like to go to the next slide, please. Introduce our two speakers for today. I'm going to introduce them both, and then I'm going to call them onto the stage one by one. So our first speaker is Daniel Brady. Dan is a Deputy Director, Nuclear Science and Technology with Natural Resources Canada. He's been with NRCan for, a little bit over 15 years, I think, working in a variety of different roles. He has been a member of Canada's Generation 4 initiative around nuclear reactor development for many years, and he brings many years of experience in industry in developing these new technologies. Claire Harris is the Manager of Environment and Engagement for the Advanced Modular Reactor team at New Brunswick Power. Claire is responsible for site evaluation and environmental assessment, as well as engagement with First Nations and the public. She has a power engineering technology degree and has worked in areas of environmental assessment and management. And she is passionate about Indigenous inclusion in clean energy. So we're looking forward to talking a little bit about that. And with that brief introduction, I'm going to ask our first speaker to come to the main stage, and that's Dan Brady. Dan.
Thank you, Warren. So it's my pleasure to be here to provide you a short and quick overview of the federal government's perspective when it comes to small modular reactors. I am coming to you today from Ottawa, which is situated on the traditional territory of the Algonquin Anishinaabe people. Next slide, please. So briefly, I'm just going to quickly touch on small modular reactors to make sure we're all familiar with the definitions. I'm going to get into the applications and markets, I'm going to talk about the streams that were often referred to in Canada, and then I'm going to end on the action plan that the federal government released back in December. Next slide, please. So what is a small modular reactor? I think it's pretty self-explanatory in the title, but at the end of the day, small being that these units are typically under 300 megawatts electrical, so hence substantially smaller than the construction that we've seen in the past and that currently is ongoing, which typically range these days on the new sizes between 1,000 and 1,500 megawatts electrical. They're being designed to be compact, so some of them could actually fit into a gymnasium. Other ones just slightly larger, but the key here is that they're small, and because of their size, it allows for what we refer to as modular. So the modularity of the construction of these reactors. So the key here is really to build them in a factory, ship them to the site, install them, operate them, and then return them for decommissioning. And the focus of having it factory built allows for lots of potential opportunities. One, so we're talking volume, so to cost reduce to make an economical. It allows you to look at new advanced manufacturing techniques that can be used to build these reactors, looking for things to become standardized, much easier to control, quality assurance programs, and so forth. And reactor, well, that's just because it is a nuclear reactor. Nuclear energy is produced from these. And I just want to stress that these are sort of the next generation of SMR technologies. So the goal being with their enhanced safety being built in, that it does allow for some simplified designs. And as sort of touched on by Warren, the goal being that they are to be flexible. So looking at how they can support multiple industries, multiple applications, including hybrid energy systems. Next slide, please. So when we think about application and potential markets, in reality, there's probably three ways to size these reactors to fit the market. So the first one being the on-grid reactors. So these reactors are typically in the 150 to 300 megawatt size. So they're meant to be on-grid. Their primary function is supply clean electricity to the grid, replace coal-fired stations going forward to help meet the the electrification requirements going forward. The second market is linked to supporting heavy industry. Typically, the reactor sizes there would be in the 10 megawatt to 80 megawatt electrical in size, and sort of highlighted support heavy industry such as cement, steel industry, the chemical industry. Also support resource extraction industries, which is mining and the oil sands. This is because the technology may make use of either electricity and or heat. So it's sort of high to note that a lot of these new reactors that are being explored provide high temperature, high quality heat that allows for decarbonization of hard to abate heavy industries. And the third market is really the microgrid, the smaller reactors in the 1 to 10 megawatt electrical. This is really meant to support remote communities, to get them off diesel, and provides, because of their heat, and if you have sufficient power, you can look at alternate applications such as maybe a greenhouse application and so forth to grow fresh vegetables in the north. So if we go to the next slide. So in Canada, after the roadmap, which I'll touch on the next slide, industry came forward and they developed this nomenclature, what we refer to as streams, and we in the federal government have adopted it because it's a way to tell the story. The first one is called Stream 1. So this is near-term on-grid SMR. So these are larger SMRs up to 300 megawatts electrical, the goal being to build the first one in Ontario and subsequent units to be built in Saskatchewan. Ontario Power Generation is currently leading a down selection process with engagement from Saskatchewan, and they're due to announce their down selection to the final design, the final vendor, around the end of this fiscal year or early next year. We'll hear their what has been a multi-year process to down select to a single unit. With the first one, like I said, being available in the late 2020s on the grid, and the first one in Saskatchewan is estimated in the early 2030s. Stream 2 is referred to the next generation on-grid SMRs, which is being led in New Brunswick, and I'm going to let our next speaker, Claire, touch on that one and what they are doing, the great stuff they're doing in New Brunswick. So the third stream is what we refer to as typically for off-grid applications. So these are the smaller reactors that would support remote communities or smaller mining or resource extraction opportunities, especially if high temperature heat is being interested. The leading project is a consortium between Ontario Power Generation and Ultrasafe Nuclear Corporation, which are currently working through an environmental assessment process at the Canadian Nuclear Safety Commission to site and build a demonstration unit at Chalk River Laboratories. And the target date there to have that demonstration up and running is 2026. So all this to say that things are happening in Canada and things are moving forward. So this is my last slide. So back in 2018, Canada launched something called the SMR roadmap. All the information can be found online. And from the SMR roadmap was developed what we call the SMR action plan. So basically, this is a real, I would consider, cross-Canada effort with lots of collaboration from a variety of different industries. So people are asked to agree to the vision and then create principles and asked to highlight what actions they will take to support the development and demonstration of SMRs in Canada going forward. And as iterated, this is a real collaboration across Canada. To date, we have 117 participating organizations that have submitted chapters with well over 500 actions that they agree to take. I think the key here is to look at the right-hand side of the slide and sort of note the variety of different organizations that are participating. This includes government, territories, Indigenous people, communities, social and civil societies, and so forth. And today we continue to get people looking to submit and submit their chapters, and in the very near future we will hold the first high-level committee that will bring these organizations together. And with that, that was my last slide.
So much, Dan. That was great, and I think for our audience, a really nice overview of what the technologies are and how things are moving ahead. I'm glad that you touched on the action plan that's been developed here, because it's great to see so many partners coming together to work in this space. I'd like to call our next speaker up to the main stage. So Claire Harris.
Hello, can you hear me okay? Awesome. Hi, I'm coming to you today from New Brunswick, and I'm happy to be here. I'm coming to you from the traditional territory of the Wolastoqey, the Mi'kmaq, and the Pescadumigati, because, New Brunswick power impacts all of the communities of New Brunswick, and so I just wanted to acknowledge that. I'm cognizant of the time, so I'm going to run through my slides quickly so that you can ask a few questions at the end, Warren. So the activities in New Brunswick really, as Dan mentioned, we were early to participate in the SMR action plan, and we put together, we established an SMR cluster in New Brunswick, and we signed memorandums of understanding with two vendors, Moltex Energy and Arc Clean Energy. I'm going to touch on those two technologies briefly. What you're going to hear is a theme of collaboration across Canada and collaboration within New Brunswick. And we all understand that in order to address the climate change issues that we have and that we're facing, collaboration really does have to be key. So the vendors themselves, Moltex and Arc, collaborate with each other. We have an MOU, a memorandum of understanding between NB Power, Moltex, and Arc, so that we can collaborate and we can share information as appropriate. We have collaborations with University of New Brunswick, Chalk River Laboratories. We are doing a lot of work on supply chain development with our companies in New Brunswick and with the vendors. And so a lot of work is happening there. Our vision is to establish a supply chain in New Brunswick and in Canada, and to demonstrate these reactors at the Point Lepreau generating station site with fleet deployment in New Brunswick and across Canada and the world. I'll get you to go to the next slide, and I'm going to give you a brief preview of the two reactors. So we're working with Arc Clean Energy, and the reactor that we're working with them on is their Arc 100. It's a sodium-cooled fast reactor. The highlights of this, they're 100 megawatts unit. It's a 20-year fueling cycle. So we understand that from a public point of view, we need to address safety, and we need to address waste. And we understand that those are significant concerns. And so when we were looking at the technology review of this, really did focus on inherent safety characteristics and waste. So the 20-year fueling cycle was definitely one of those areas that we were very interested in, and also their inherent safety characteristics and passive safety operation. The next unit that we're looking at, the next technology that we're working with, is Moltex Energy. This is a 300 megawatt unit, and both of these are depressurized pool reactors, and so they have inherent safety characteristics also. The other characteristic of the Moltex Energy reactor is the fact that it is designed to use the used fuel from the CANDU reactor that we're operating today to fuel this reactor. So essentially, reprocess that fuel and reuse it in reuse that energy in a reactor. So the fuel that we have on site at Point Lepreau today is adequate to run this unit for 60 years. And so really we're going to be reusing, recycling the fuel that we have on site today. So that's just a high level overview of the two technologies. I'll get you to go to the next slide. We have been focused on Indigenous inclusion, and purposely, it's inclusion. Our overall objective is to partner with our Indigenous communities of New Brunswick as a tri-party, a collaboration. New Brunswick Power, Moltex, and ARC have developed an Indigenous inclusion guide, and we're using that guide to collaborate with each other and collaborate with the Indigenous communities of New Brunswick. So we're working with all 16 communities. We are out there ensuring that we're listening, that we're building the relationships, and that we're understanding the Indigenous knowledge and the Indigenous points of view that we'll need to keep in mind throughout this program. Next slide. We know that one of the biggest concerns is going to be from a social acceptance, social understanding. And I like this quote from Bill Gates' new book. Convincing people about nuclear power may be more difficult than actually building a nuclear power plant. And we understand that. And we need to make sure that we're listening to the concerns and that we're addressing the concerns as we continue to build on these programs. I'll get you to go to the next slide. That picture actually was from Glasgow, and it was a young generation of nuclear members. And if you're looking for something that is really, it's great to watch. They did a flash mob in Glasgow during the COP26, and they did a great job. So I would welcome you to go have a look at that. From a social acceptance point of view, the cluster got together with Atlantica Center for Energy, which looks at the whole region from an energy point of view. And we developed what's called the Atlantic Clean Energy Alliance. And that's really a collaboration of wind companies, solar companies, SMRs, and conventional nuclear. And we really do want to act in the spirit of collaboration and understand what we all need to do in order to address climate change. We have that tri-party approach that I spoke to on the Indigenous inclusion. We also do that on the public engagement, and we want to get the right information in the right hands, and we want to listen, and understand what the concerns are. A lot of youth engagement is happening. We're working with our elected officials, and we're really just getting out there with our community groups and our public engagement to make sure that we can address the social concerns. That's really what I wanted to talk about today. And I just wanted to turn it back over to you, Warren, for any questions that you may have. Oh, I think you might.
Oh, there we go. Thank you so much for that, Claire. That was a tremendous overview. And I've got to say, I'm just so impressed by the program that's coming together in New Brunswick, and the process that you're following is really interesting to see. And I know that our viewers will be really interested to know what's going on. I want to just address a couple of questions. We have a few minutes left in our session, and I know that time is tight for everyone. And Claire, you've started to get into some of these big challenges going forward, but I'd like to put that out really clearly. Like, what are the biggest challenges that this particular technology or this approach is facing over the next decade? How can we realize the potentials of the technologies? Are there things that we need to be doing now? So maybe I'll go to Dan first and then come back around to Claire.
Sure, thank you.
I think Claire, her presentation really touched on it. It's public confidence in the technology and getting buy-in from the municipalities, from the communities, from the larger public in general, and the Indigenous people as well. And that to me is the biggest challenge going forward. Once you have that, then you get political officials on side and life becomes simpler. So I think Claire's done a great job highlighting activities in New Brunswick. Same things are happening within other jurisdictions as well to build and support that public confidence, which, going forward, we have to be open, transparent, and engaging on the topic and willing to have the hard conversations on the tough topics.
That's great. Thanks, Dan. And Claire, did you want to add to what you'd said in your presentation?
No, but I would add that, on something this complex and the pan-Canadian approach, I think we sometimes think, okay, we've done it, we've had all the conversations that we need to have, and then you find out that there's a large group of people who really don't understand what it is that we're trying to do. And so, it takes a lot of work, and we just need to keep getting down to that next level and across different silos, because a lot of conversations are happening. It's all about collaboration and bringing those conversations together.
Thanks for that. And I do think that having ongoing conversations, not in and out, quick discussions, but rather real engagement is critical. And speaking as somebody who's in the academic sector, this is something that we're very interested in helping to facilitate. So as we go forward, I hope we can play a role there. I just want to ask one last question, and this is kind of the big open-ended question. What are the gaps in our approach going forward? Are there things that we're not doing that we should be doing? Are there things that maybe we're not paying enough attention to? We've talked about the engagement piece, but maybe there are other things out there. And again, maybe I'll start with Dan, and I'll come back to Claire.
There's probably quite a few different gaps. It all depends on what you're looking for gaps. I mean, sort of linked to this, and this is all new technology, so there's a lot of stuff that still need to be addressed, like that Claire raised on the waste and understanding the waste streams and so forth. In addition to that, people do have concerns about security and non-proliferation. So those are also topics that, from a federal government perspective, we're working with our partners and the provinces, trying to understand if there's gaps in policies, gaps in legislations, that could hinder and not help facilitate moving the technology forward. Maybe I'll hand it to Claire quickly.
Okay.
Sure.
Yeah, I agree with what you said, Dan, and I think that one of the things that we need to focus on is less competition, more collaboration. If we're all going to work together across Canada to make this happen, I think we can share a lot of information, from department to department and up and down and across when it comes to the technologies, sharing information with each other, because we're going to need a lot. And so it's not, I think if we share more information, that we'll actually learn more from each other than we might know. And so, I know that we're running out of time, but yeah, that's one of the key things. I think less competition, more collaboration.
Okay, so I am being told that there are a couple extra seconds, and I know that there are a couple of questions in our Q&A. I just want to kind of summarize them, and then I'll ask the two panelists if there's any responses they want to make. So 2 questions that have come up are, how do we feel about SMR as a good technology option for Indigenous groups? I think we've talked about that a little bit. It's not thinking about it as a good option, but rather understanding that Indigenous nations are an important partner in developing these technologies. And then from the same audience member, could we share some economic data about SMR compared to other technologies? So keep that in mind, both Dan and Claire, economics. The last question in our chat is, do we predict an excess of the CANDU fuel, so the fuel from the old reactors for the new reactors? Or is there a limitation to how this stuff could be moved around or shared, or would it all have to be used on site? So one very technical question and one economic question. And why don't we just go in the same order that we've been going? So I'll ask Dan, and then Claire will get the last word.
Okay. Regards to like Indigenous communities need to be part of the conversation, need to be part of the dialogue, and you know, there's lots of potential opportunities, but at the end of the day, you know, for their communities and within their communities, they will make their own decisions on how they would like to move forward. Regards to economics, it is a question that keep coming up. They're going to need to be cost competitive with other opportunity, like other clean energy sources over the long term. I think we do need to look at life cycle analysis and stuff like that. But in, you know, it's one of those things where the whole purpose to make it viable is the modularity, factory construction, and looking at a fleet approach. A single off unit is not going to be economically viable. So I don't have a hard number on you. We can always have a conversation afterwards and can look at it. Regards to the fuel, spent CANDU fuel, I think it's an opportunity there to. It is an untapped resources that New Brunswick is definitely looking at. And I'm going to let probably Claire do more of the answer on that, because they've probably looked into a lot more versus, you know, distributing and staying on site and so forth. So maybe I'll let Claire dive into that one.
Yeah, the Moltex design is really in the research and development phase right now, and the plan would be that you know, if there's a facility, it would be alongside the facility that's that we're going to be using the fuel from. So you wouldn't, you know, the plan is not to bring you know, fuel to New Brunswick to use. It's to develop you know, the facility here, test it here, and then, you know, build a new facility where it's required at the alongside the nuclear power plant that would have the used fuel available. Does that answer your question appropriately?
I think that does address the question that had come up. And, you know, what these questions are saying to me is that there's a lot of interest in this topic.
Yes.
And, you know, when I started investigating small modular reactors as someone who focuses on the policy end of the equation, I was quite amazed at some of the things that the technology can do for us. And, you know, as we're coming to the end of the session here, I do want to say that, you know, I've learned a lot just in the last half hour, in the last 30 minutes. I think that there is a real healthy appetite to learn more about these technologies. So I really take the point that, you know, we need to keep these conversations going. I think that there is a lot of potential here, but it needs to be a dialogue and it needs to be explored. And I think that lesson is being heard loud and clear. So in respect of time, because they've actually been very generous with us and given us a few extra minutes, I do want to draw our session to a close. I want to take a moment to thank both of our speakers. So Dan and Claire, I know you've taken a lot of time out of your schedules to join us. It's been incredibly helpful. And, you know, as I say, I've learned a lot, and I think the audience has learned a lot. And I'd like to thank the organizers of the conference for allowing us to put this on. And with that, I can hand it back to the organizers and say thank you to everybody.
Thank you. Thank you. Reach out to myself if you need anything or would like more information. I'd love to talk to anyone.
Great.
Thank you.
Thanks very much. So we can sign off at this end.